Good day, students. Welcome to part 2 of the Geometry Regents exam for January 2013. On this installment, we're going to be going over questions 6 through 10. Okay. All right. Let's start out by taking a look at question number 6. It says plane A and B are two distinct planes that are both perpendicular to a line L. Which statement about planes A and B is true? Alright, so option 1 says planes A and B have a common edge which forms a line. That option is incorrect because we're told that the planes are what? They are both distinct, which means they're separate planes that do not intersect. So there is no way they can have a common edge if they were two distinct planes, okay? Two planes that have a common edge are going to be non-distinct planes. So since the planes are distinct, that means that they cannot have a common edge. Option 2 says plane A and B are perpendicular to each other. If plane A and B are perpendicular to each other, that means that one of them cannot be perpendicular to line L. Okay? To help you illustrate the situation, let's say this is your line L right here. And if this is plane A, and if plane B is perpendicular to plane A in this orientation, then what does that tell us? So this is line L, this is plane A and plane B. If plane B is perpendicular to plane A, then it is going to be parallel to line L. You see that? But in the initial condition, we're told that both planes are perpendicular to L. So if the two planes are perpendicular to each other, one of the planes must be perpendicular to line L. Hence, it violates this original condition for both of them to be perpendicular to L. So option 2 is wrong because if both are perpendicular, one must be parallel to L. Okay? Alright, option 3 says they both intersect at exactly one point. This makes absolutely no sense. Planes cannot intersect at a point. It is impossible to come up with two planes that intersect at exactly one point. Planes intersect at a line. Okay, the intersection of planes form a line. Let me show you an example of what I'm talking about. Alright, so what you have here is two planes intersecting, and you see how they intersect, right? They intersect at a line, alright? So planes cannot, it doesn't make sense for planes to intersect at a point. When planes intersect, they intersect at a line. But when when lines intersect basically at a point. So that just helps us see that it is impossible. It makes absolutely no sense for planes to intersect on. So we can clearly see that option 3 makes no sense because when two planes intersect, they intersect at the line. Okay, so option 3 makes no sense, and it has to be option 4. So it says planes A and B are parallel to each other. That makes perfect sense because let's go back to this sketch I made right here. I'm going to take out plane B. Let's take that out. Take out plane B. Um, and there you have the line L. And then let's draw the angle that indicates perpendicularity. So A is parallel to L. Okay, let's assume that this line contains um, the plane. The plane contains this line. So if we draw the next plane, a line that the plane B contains perpendicular to L, something like that, then we see how the case makes sense. So this is plane B right here. Okay, so we see that if they're both perpendicular to this line, then they're both perpendicular to each other. So, I mean, they're parallel to each other. Any line on the plane, on this plane, is going to be parallel to this line. So this makes perfect sense. So there you have it. All right. So what I just did here is I just showed you the planes that contains the two lines I drew earlier, and you can clearly see how the planes are parallel to each other. So plane A is parallel to plane B because they're both perpendicular to this line, so this makes perfect sense. So our correct answer is option number 4. All right, let's move on to question 7. It says in triangle ABC is similar to triangle DEF. The length of sides AB of triangle ABC is 5, 8, 11. What is the length of the shortest side of triangle DEF if its perimeter is 60? Okay, so We have two similar triangles, so let's go ahead and sketch the situation. All right, so there goes two similar triangles. Let's go ahead and label it. Let's say this is triangle ABC, ABC, and then this triangle right here is triangle DEF. Now, if they're similar, that means that we're going to be dilating each side by the same factor, okay? So, so let's say that the side measures are as follows. So let's call this 5, 8, and 11. All right, these two triangles are similar, so there has to be a dilation factor. So let's say the dilation factor from this triangle to this triangle is by a factor of x, okay? So we're going to multiply each side by a factor of x, and that's going to dilate each side, okay? So to go from this side to this side is going to be scaling it by a factor of x, so this side is going to be 5x. And then to dilate this side to this side, we're scaling it by a factor of x, so this is going to be 8x. And this side is going to be 11x, okay? So anytime you have similar triangles, every corresponding sides are in proportion, basically multiplying by the same number to generate the corresponding sides of the similar triangle, all right? So we know that the perimeter of the image or the other triangle, the bigger triangle, is 60. So can we formulate an algebraic equation using that information? Absolutely. We know that the perimeter of a circle is of a shape is the distance around it. So in this triangle is the sum of the measures of the three sides, okay? So we know that 5x plus 8x plus 11x is going to yield the perimeter, which is 60. Okay, so let's go ahead and solve this. When we solve this, we're going to have 8 plus 5 is 13 plus 11 is 24. So we have 24x equals 60. Now to get x by itself, divide both sides by 24. And then we have x equals, to reduce this, 12 goes into both sides. So divide top and bottom by 12. 12 and a 60 is, 60 divided by 12 is 5, and then 24 divided by 12 is 2. So x is 5 over 2. Okay? All right, so the question was, what is the length of the shortest side? This is the shortest side right here. So all we just do is we compute 5x. Okay? But x is 5 over 2, right? So the shortest side is 5 times 5 over 2. And then that is 25 over 2, because you put this over 1, multiply the top and the bottom, you have 25 over 2 in decimal form. This is 12.5. Okay, 2 goes into 2, 1, carry 1. 2 goes into 2, it's just 1, and 2 goes into 5, 2.5 times. So there goes the length of the shortest side. So our final answer is option number 2. All right, let's move on to the next question. In problem 8, we're told that in the diagram below is of a right triangle ABC, and the altitude CD is drawn to hypotenuse AB. So whenever you have this case, what you have is you have three similar triangles, okay? We have three similar triangles. So we're given information about the shortest side of the smallest triangle, and then also we're given the information of the second to the shortest side of the second triangle. So to help us solve this problem, let's identify what we're looking for. We're looking for the length of the altitude, so let's call that x. So we're going to use similar triangles to solve this problem, but in order for us to make it easy to understand, what we're going to do is we're going to separate these two triangles, okay? We can separate them, then it's easy for us to see. So what I'm going to do is, let me first of all draw triangle CDB. I just make a sketch right here. This is triangle CDB right here. Okay, so this is triangle number 2, second to the largest triangle, CDB. CDB. All right, this is a 90-degree angle. This is the x we're looking for, and this side right here is 12. We are also given the information of the shortest side of this triangle CDA. But let me orient triangle CDA in the same orientation as triangle CDB so I can see identify the corresponding sides and set up my ratio accurately, okay? So I'm going to rotate it around like this. That's triangle CDB. So this triangle right here, I'm going to rotate it and make it look like that, okay? What I'm doing is I am pairing up, you see the 90-degree is right here for CDB. So my 90 degrees is going to be here, all right? And this is going to be D, this D point, and then this is going to be A, and this is going to be C. For triangle CDA, I just took this triangle, rotated it right here. We know that AD is 3, and this CD right here is exactly the same as this CD, which is X, okay? So we have two similar triangles, and we know corresponding size and proportion. So we can set up a ratio here and solve for X, okay? So we can say we know CD corresponds to AD, and BB corresponds to BC, so we can say X over 3, this side over this side, equals 12 over X. 12 over X. Okay? So if we solve that for X, that will tell us what CD measures. Okay, so let's go ahead and solve this. We can cross multiply. If we cross multiply, we'll have X squared equals 36. And then to get X by itself, you just take the square root of both sides. Square root this, square root that, and then you get X equals 6. And that's the measure of CD. Okay, so the trick here is basically separating the triangles and putting them in the same orientation so you can actually match the accurate corresponding sides when setting up your ratio of similarity. Okay, so anytime you draw an altitude of a right triangle, you're going to create 3 similar triangles and you can use similarity to solve them. All right, let's move on to question number 9. Question 9 says the diagram below shows the construction of an equilateral triangle. Which statement justifies the construction? So what we're doing here is we're using a compass and we're creating multiple arcs, okay? So if you look at the arc, first of all, you place your compass here, and then you create your first arc. All you're doing is you're taking segment AB and you're creating AC with your straight edge. So you have 2 congruent arcs. So this basically tells you that AB is equal to AC because they're like the radius of a circle, a bigger circle, okay? So this segment right here is congruent to that segment. Now what the constructor did is they used the same AB segment, switched the compass around to put the pin here, and then put the pencil here, and then they created another arc. So what does that tell us? It tells us that CB is congruent to the other 2 measures that we created, is congruent to AB also. Okay, so that is also equal to CB. So when in this construction, all you're doing is you're basically using the same measure and you're creating 3 sides of a triangle. All right. So the statement that justifies this construction has to do with just the side lengths. So it cannot be this nor that. Answer is option number 3 because it actually involves using segments with arcs to create an equilateral triangle. All right. So there you have it. All right, let's take a look at option number 10. It says, what is the slope of a line perpendicular to the line represented by the equation 2x plus 4y equals 12? Now, there are 2 ways of doing this. One way is, notice this equation is in standard form. So if you have an equation in standard form, ax plus by equals c, the slope, m, is given by negative a over b. Okay? And the slope of a line perpendicular to it is the inverse of that slope, the negative reciprocal. So the slope of this line is negative a over b. The slope of a line perpendicular to this line is going to be the negative of the reciprocal of negative b over a, which is simply b over a. Okay? So the slope of this line is negative a over b. The slope of a line perpendicular to this line is simply b over a. Okay? So in this triangle, in this line, in this line 2x plus 4y equals 12, we see that b is 4 and a is 2. So we can simply conclude that the slope of a perpendicular line, which is b over a, is simply 4 over 2, which equals 2. End of story. Okay? Another way to do it is, let's find the slope of this line. To find the slope of this line, we can use the formula m equals negative a over b, right? So a is 2 and b is 4. If you simplify this, you have negative 1/2. Now, what is the slope of a line perpendicular to this? Is the inverse. What is the inverse of negative 1/2? It is the opposite of the reciprocal, which is simply negative 2 over 1, which equals 2. And there goes your final answer. Okay? All right. This is method 1 using a over b. Now, another method you can use is putting it in slope-intercept form, extracting the slope, and then computing the inverse. Okay, so let's do that. You learned this in algebra, 2x plus 4y. If I put it in y equals mx plus v form, then m will be the slope of the line, and then we can do the negative reciprocation to determine what the slope of the perpendicular line is, okay? So method 2, let's put it in y equals mx plus v form. To accomplish that, we'll subtract 2x from both sides, and we will have 4y equals negative 2x plus 12. To isolate y, we divide every single term by 4, 4, 4. Okay? So now we're going to have y equals negative 1/2 x plus 3. Okay? So what does this tell me about the slope of this line? This tells me that the slope of this line is negative 1/2. Okay, like we determined earlier. You see how fast the other method was? We didn't have to do any algebra here. We just plug the negative over v and we got negative 1/2 real quick. But this one we actually had to do a lot of work. All right. So if this is the slope of a line of this line, then what is the slope of a line perpendicular to it? It is the negative reciprocal, right? Or the inverse. So the negative reciprocal of that is going to be negative 2 over 1. All right, and then we multiply it out to get 2 as the slope of a line perpendicular to this line right here. So we can clearly see, using both methods, that the answer is option number 2. All right, so there you have it. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking in here so you can get updates to the next installments to this review series. Please post a comment to let me know what you think about this. More videos can be found on Mathgotserved.com. Thanks again and have a wonderful day.